Today we're going to narrow down our functions to the absolute value function and its graph. A lot of the notes today are going to look a lot like yesterday's, except for we're only going to be talking about the absolute value function. As you see here, absolute value function creates a v, and the parent function, which is f of x or y equals the absolute value of x, has a vertex that touches the origin. A vertex is the high point or the low point of a graph, and seeing as how an absolute value goes to infinity, it can only have one or the other. So this would be considered a low point. And we also have a new term up here called axis of symmetry. Axis of symmetry is a line that would cut your graph in half. So if I had a line, if I could just take this line and draw it right through the vertex, I could fold this graph over and it would be symmetric on both sides, meaning it would be exactly the same on both sides. So that's what axis of symmetry is. Axis of symmetry is always written as x equals, and it'll be a number, and the actual number is the x value of your vertex. So in this case, it'd be x equals 0. Hopefully these notes here look pretty familiar. They're the exact same notes that we had from yesterday's lesson, except for the fact that everywhere you see f of x yesterday is replaced with the absolute value of x today. So same thing. We talked about vertical translations moving up and down. We talked about horizontal translations moving left and right. We talked about reflecting over an axis, and we talked about stretches and compressions. They're all the same. So there you go. Here we have a pretty normal multiple choice question that you might see on an SAT, ACT, PERT exam, any of your standardized testing give you questions that are somewhat like this, where you have to match a graph to an equation or to a function. And basically it's just seeing if you understand how to transform a parent graph to a new graph. So the parent graph would be obviously be y equals absolute value of x, and we have transformations where I add 3, add 2, all that kind of stuff. So if you remember from yesterday, when I have a plus 3 on the outside, that is a vertical transformation. So plus 3 would be going up 3. Well, in multiple choice world, I can get rid of this guy and this guy because they actually went down 3. So that's a test taking skill for multiple choice tests. Get rid of some answers that you know for sure are wrong. And then on the inside, remember there are parentheses here. On the inside of this absolute value, we have x plus 2, and we need to get that 2 out of there. So we change its sign. Remember, what we're really doing is we're setting the parentheses equal to 0, and we're solving for x. But the quick and easy way to do it is just take it out, change its sign. Really, we should divide by the number in front of the x, which is just a 1, and that's going to give us a -2. And that will tell us whether we move left or right. Well, -2 says we should move to the left. And that gets rid of b over here because that one moved to the right. And we are left with this. Now look at this. This is our vertex right here. And that vertex, if I made you write it out, would be -2, 3. Those were the two movements that we just did. So actually the vertex is the movements. It's your horizontal movement and your vertical movement, just written in vertex form. Here we have the general form of an absolute value function. You're going to see general forms of functions all year long, so you might as well just get used to it now. The general form here is we'll almost always have a y and an x, and then some other variables that actually turn into numbers when we write them out in regular form. The 3 things that will change to numbers in a absolute value are the a, the h, and the k. And you can see over here that the vertex is h, k. Well, we just kind of did that. That's our movements. That's our horizontal and our vertical movements. The a over here is, it's like a coefficient, and seeing as how absolute value look like lines, I actually kind of do this, and I say it's, in quotation, it's the slope. And I put quotations around it because it's not really a slope. Slope is only for a line. But this is kind of like 2 lines coming together and we can think of it as the slope. So in class, I've always been air quoting when I say the word slope. So whenever I say slope here, picture me air quoting it, because it's not exactly a slope, but it's kind of like a slope. So we're gonna kind of think of it as a slope for a little bit. All right, so here we have an example that I give you a pretty involved absolute value function, and I'm asking you to do something. There's two things I could ask you to do. I could ask you to describe it, meaning describe the transformation, or I could ask you to graph it, and we're going to do both right now. So when you describe a transformation, I want you to talk about all four things that could happen. All right, and the four things are, they could go up or down, that's one. They could go left or right, that's two. They could flip over the x or flip over the y, that's three. And they can compress or stretch, that's four. All right, the plus signs and the minus signs are your transformations, that's one and two. One and two are transformations. So up or down, I see a +4 on the outside, so I'm going to say up 4. And then I look at the inside of the parentheses, I have x minus 2. I'm really setting that equal to 0 and adding 2 divided by 1 and get a positive 2. Positive in horizontal is right, so I say right 2. And then the next thing I look for is flips, meaning is it going to flip over the x-axis, flip over the y-axis, also known as a reflection. What I'm really looking for to tell if there's a reflection is a negative. So if I were to read this, would I ever say the word negative? So let's read it. Y equals 3 times the absolute value of x minus 2 plus 4. Did I ever say the word negative? Nope. So there is no flips, no reflections. Reflections is too big, so I just write flips. And last but not least, is it a compression or is it a stretch? So here's what a normal, well, that's terrible. Let's try that again. See if I can make it a little bit straighter. Here's a normal graph for absolute value. Now, let's put a y-axis and an x-axis on there. All right. So if you remember last year when you guys did dilations, if I gave you a rectangle and I want you to dilate it by 3, what happened to that rectangle? It got larger, right? Well, when I put a 3 in front of absolute value, I'm going to make this larger. And when I mean make it larger, I'm talking about the y values. So right now the y value, like this y value would be here and this y value would be here. Well, I want to make them larger, so I'm going to pull them straight up, right? And it ends up, like if it got pulled up to here, what happens to my graph? It got stretched up, right? Or if it was a 1/3 over here, you'd actually compress your numbers down. You'd make them smaller. So if I wanted to make my y values smaller, I could compress them down to here, and my graph would look like this. All right. So since this is a 3, we are going to go ahead and write that it is a stretch. All right, so now let's come over here and graph it. When you're graphing an absolute value, the first thing you want to do is graph the vertex. And remember, the vertex is the movement. All right, up and down would be a y value, so we went up 4, that's a positive 4. Left and right would be an x value, we went positive 2, went to the right, so it's a positive 2. So I'm going to graph 2, 4. So 1, 2, 1, 2, 3, 4. Put a little dot there. We said that there was no flips, so I know that it's going to go up, and it's a stretch. Well, remember, 3 is slope. Air quotes were there, slope. So I'm going to go up 3, 1, 2, 3, over 1, go up 3 over 1, and there is my graph. You can see how it's not a normal 90 degrees. A normal absolute value graph would be 90 degrees in between here. That's obviously got squished down a little bit. So it got a little bit skinnier because I stretched it up, and there's the transformation. Last but not least, we're going to go the other direction. I give you a graph, and I want you to tell me what the equation was. So remember, the equation when we're done is going to look like this. Y equals ax minus h plus k, where this is going to be a number, this is going to be a number, and this is going to be a number. Well, the first thing I like to do is to find the vertex, and there's the vertex right there, right? So what number is that? I believe that is -1,4, right? So we can go ahead and put those numbers into the equation, all right? The x is going to go in the absolute value, the x value of the vertex. This guy right here is going to go in here. And remember, it's in parentheses, so I got to change its sign. The k of the y value goes on the outside. I don't have to change its sign, so it's +4. And now all I got to do is worry about that a. Remember, the a is, air quotes, the slope. So if I can figure out the slope of this line, I can put it in for a. So I'm going to go from this point right here, the vertex, which is on a corner, to this point, which is on a corner, and I get 1/3. Now right now, I wrote it down as a +1/3, but I need to take a step back, look at the graph overall as a whole to see if it's a positive graph or a negative graph. Well, that is opening down, right? The V opens down, so our last bit is to put a little negative right there in front of it, and this would be the equation for that function. And that's it.